Hello. Good afternoon, everyone, and thank you for joining us today. Welcome to the first episode of Frontline Insights. My name is Raymond Hanna, and I will be your host today. And we are honored to have Andrew and Sam as speakers for us today. Andrew will tell us about streamlining sleep services and automating outpatient clinic preparation, and Sam will talk us through some of the bits about the robotic process automation. Some great stuff, and can't wait to hear all about it. If you have any questions, please put in the comments, and at the end of the session, we will be able to go through them and ask Sam and Andrew all of the questions that you have. First, Andrew, would you like to tell us about yourself and sort of your journey, and then tell us about the great work that you've been doing?
So I'm Andrew. I'm a clinical scientist at James Cook Hospital in Middlesbrough. I started out as a software developer and retrained in 2019 as a clinical scientist. But I'll probably go through a little bit more of that on my slide as well. But yeah, nice to meet you all. Let's share my screen, bear with a second. There we go. So I'm going to talk today about a piece of software that we developed in-house to help our sleep diagnostic clinic management system. So a little bit about me. So as I said, I graduated in 2011 with a degree in computing and networks. I studied a master's in computer science, and I'm working as a clinical scientist in physiological measurement at James Cook Hospital. So I retrained back in 2019, undertaking what we call the Association of Clinical Scientists Route 2 in my area. And now I'm combining my software skills with healthcare. And a fun fact for me is I didn't enjoy software at university. I didn't get on with software. I preferred the IT and the network side of it, but now I just love software now, so a bit of a change. So a little bit of the background of the problem that we were trying to solve. So those you are aware of sleep disorder breathing, so we run a sleep diagnostics clinic where we test our patients once a week by using an overnight oximeter. So to do this, we book them into the clinic on our patient administration system called CAMIS. Some hospitals may use CAMIS, and we use CAMIS. So to do this, the clinic sheet was printed out, taken to the clinic. The equipment was issued to the patient and then handwritten on a clinic sheet. And then the instructions are provided to the patient, and then they returned the overnight oximetry equipment back to the hospital reception a couple of days later. Then on the Monday, when everybody's back at work, we matched up all the equipment against the paper records. The results were then uploaded manually, but these were to an old Access database, and then clinical scientists would perform quality control on the Access database. We'd look at the results on the end and release them on the Access database. But this is the tip of the iceberg, so it's a really fast nutshell of the background problem that we're trying to solve. So this is what we sort of came up with. So we needed a complete new solution, and what I set out to do was integrate to the hospital patient administration system via something called ODBC, Open Database Connectivity, by creating a C# desktop app. We also created a barcode scanner as well to check the equipment that came back to the reception, and a web app to manage all the appointments, all whilst trying to balance the challenges of hospital IT, as doing this is not in a software development team in the hospital, but in a department developing software external to Trust IT as it is. So I'll get right into the solution that we developed. So this is a little bit of play on words here. So this software, Sleep Talk, this is our interfacing software. So this software connects to our patient administration system by ODBC, and I can register the clinics, sync consultant clinics, register patients manually, and also sync manual appointments. But we'll talk about those as we go through. But this is the look and feel of the C# desktop application that I created. So you can see here, I want to register one of our oximetry clinics code is 25070OP. That's just the clinic codes that we give them, and the date is coming up on Thursday, the 18th of July. Now, this pulls all the information out of CAMIS and puts it onto a table right in front of us on the screen there. And then what our healthcare science assistant would do is they would click register clinic, and that would pull all of the data out of CAMIS and put it into our own SQL server database for our web app. So that's how we get all the data out. So that was one challenge that we had to address, was getting that data out of our pass and into our own software, because we can't really access the pass to manipulate the data, unfortunately. This window here is just to manually register a patient. So if we go back here, so if a patient isn't on here, one problem that we do have is if the clinic, we can't register them on the day of the clinic because the clinic locks up, so the database is locked, so we can't import new patients. So we may have a situation where we manually register a patient. So you can see here, there's a facility to add the hospital number or the NHS number, and we can register them manually, and that'll pull them into the database for us. And that's just, again, just an overview of the screen. So this is our workhorse. This is basically our interface tool that we use to pull the data from CAMIS. Now, moving on to Sleep Cloud. So the web app, the nicer part, the bit that was a bit easier and a pleasure to develop, was the C# web app that we have here. So at first, the user's presented with a dashboard which shows us some outstanding tasks. So you can see there we've got 8 out of 62 boxes issued. We've got 3 that are ready to download, 38 WatchPats. Some of you may be familiar with WatchPat. These are equipments that we hand out to the patient for sleep studies, just a different type of equipment. And there's also some more tasks at the bottom. For example, 8 SMS messages to send. And now, so as I was saying before, we register our clinic. So once we go into appointment management, we can click our clinic, navigate into the clinic that we want. So this is a test one here. All test details for this one, all patient data is anonymized for obvious reasons. But the user is presented with this window now where they can see the list of patients. You can see there. So you've got that 12 o'clock, but normally they'll be populated with every 10 minutes slots there. And then the user can go into the manage the appointment. So if they click manage the appointment, they're then presented with this window. So this is where it's made it a lot easier for us now in terms of managing our equipment. So we've pulled the data out of CAMIS. We now see it on our web app here. We can see all the information that we need. So the appointment information, the priority, whether it's routine or urgent, a bit of information of where the referral came from, whether that was eCAMIS or Choose and Book, the e-referral service. A mobile number as well. And also, if you look on the right-hand side there, you can see the equipment there. So we've got a drop-down list of the equipment that is available to assign to this patient. This is where we've now got rid of the paper-based process where we had to write down manually on a piece of paper. That paper would be stored in a filing cabinet, then retrieved again. So now we issued the patient the oximetry equipment there. And as an additional with this now, it also creates comments automatically. So if you can see there on the bottom left there, my colleague there, he issued a patient with a WatchPat 28. You can see that they've gained consent for mobile text messaging. And then we can also send text reminders as well. So patients who don't bring their equipment back, we can now automatically say, well, we can hit a button and say, send that reminder to them to bring their equipment back, and it sends that text message there. And I'll go on to where that text message comes from in a little bit. And we can also add our own manual comments in there as well, if we want. So this is something that we didn't have before. We couldn't. So if we're in the clinic with a patient, we can just type up information there. It's a bit of communication between ourselves as well, which is quite nice. So we've issued the boxes to the patient. Now, clinic's finished. We've gone home. We're back on Friday, and now we can see who has our equipment now. So you can see on this window here, the equipment information on the left column, the date it was issued, how it was issued, so posted. So we have a posted flag here. The ones that weren't posted, we don't have anything on. And you can also see how long the patients have had the equipment out for. And you can see this one here has had it for nearly 40 days and is definitely overdue. So when we issue it on a Thursday, we say, can you bring it back by Monday? So it doesn't always happen, unfortunately, but at least it gives us a bit of an idea of where our equipment is. You may notice that I've got the sleep cloud button here on the right hand side as well, actually, because we're also in the process of developing version 2 of this software in .NET 6. So we're running 2 side by side almost while we're migrating across. So this is the equipment that has been issued. So now the patient will come back into the hospital, use our barcode scanner, which I'll show you a little bit later on, a picture of that in a minute. So as soon as the patient scans it back in, it then pops up into our list of returned boxes ready for downloading. So you can see here what box was returned, when they were returned, who were the patient who used it, and their NHS number, and we can manage it there. So we manage oximeters in this software, and we manage our watch pads in Sleep Cloud version 2. So we are splitting across 2 systems, but it's slowly coming together as we migrate. And here we are. So here's our famous barcode scanner. So this was developed by one of our engineers in-house. Fortunately, in our department, we have access to an engineer who's fantastic at developing hardware, physical devices. You can see here that the housing, this is a prototype, but this housing was all manufactured by ourselves in our workshop. So it's just really good resource to have. But within our barcode scanner, so you can see, actually, if you look on the bottom left side, you can see our equipment box there. So there's our barcode there. It uses blue light just so the barcode scanner can see the barcode because it was a bit dark. I did have an interesting question that somebody thought it was a UV light that we were cleaning them as they were going. That's quite an interesting idea, but it's not UV. It's just a blue light just to keep the barcode visible to the scanner. So on the right hand side here, surprisingly easy setup, this one. So for this, what we're using is a Raspberry Pi with a touch screen. I think it's about 10 inch, possibly about 10 inch, can't remember exactly, but a touch screen, Raspberry Pi, power supply, and just an off-the-shelf barcode scanner there. And then that's connected to our network. And that's located at our south reception there at the hospital. So the patients will put the device under there, it will scan it, it will call our, what we call the API, application programmable interface, and then it marks the box back as returned in the database. So then we've got that queue of boxes that we know that are back to download. This is just a snippet of the code that we've developed. So the barcode scanner software itself was developed in Python. So just as an example of, we've used C# to develop a lot of the Windows-based things, such as the web app and the desktop application for managing the clinic. Whereas the barcode scanner itself, we've used Python because it's really quick, lightweight, and just does the job for us and works really well on a Raspberry Pi. So I mentioned about the text messages. So we have access to something called GovUK Notify. A lot of hospitals can access this. If I remember correctly, I think you can get 4,000 text messages for free. I'm not too sure if that's per year or per month, but I do encourage you to go away and have a look at that. You should be able to sign up and get those 4,000 for free. Fortunately, our trust buys into the service, so we don't have a limit of text messages that we can send. But you can see here, if you look at the bottom left, this is one of our templates. So this is our postal equipment template. So in the software where I've got my send text message button, we can press that button and it calls the Gov Notify API. And then it just sends this message to the patient's phone number. So as again, GovUK Notify have their own API, and they've also got, if you're familiar with C#, they have their own NuGet library as well that you can import, which makes it really easy to use and straightforward to send text messages to patients, which is really helpful because in this day and age now, sending that text message to the patient just to remind them. As you can see in the bottom right there, we can send that reminder that they haven't returned their equipment on the date that they've collected it. And also on the top right, so when the patient scans the equipment back in, It gives them a little bit of feedback that we've got the test back, it's recorded successfully, and now they're waiting for an appointment. And this is what it looks like to the user. So just a couple of text messages there. You can see there. The first one is to confirm that we've received the equipment back. And the second two are just duplicates of where we've tested this post out equipment. And again, I think this is, I probably should have put on the presentation, but what we found by doing this has actually decreased our equipment loss rate and also decreased our DNA rate as well, because we also send patients reminders that their appointment's coming up. So, bit of a whistle-stop tour there, and I believe there's some time for questions later on to discuss. If there's any questions, please do ask in the chat. But some of the future that we're looking at is, so the Sleep Talk app that we have, I would like to automate it by creating a service. So I would like it to sort of like every evening at 6 and every morning at 6, pull in the clinic automatically instead of doing that manually. That would be really handy if we can do that. The reason why we chose to do it manually now is a little bit of governance as well, so we can have a bit of control over the data that we come in, just in case it goes a bit haywire. But fortunately, so far it's been really good. Another interesting future work that we're really looking at is actually, so we do have the barcode scanner, but we're looking at doing QR codes or perhaps radio frequency IDs. This is because, although it's not happening yet, there is a potential where somebody could just print out a barcode and just try different barcodes and scan them in the device and see if it returns someone's equipment. So there's there is a bit of a possibility there, but with RFID, that sort of eliminates that possibility. Well, not eliminates it, but reduces that risk of somebody doing that. And also what we're quite interested in is better management of DNA. So we do record DNAs in the system, but it would be good to sort of, our next step would be to sort of create a task. So the Sleep Cloud system now is really good at creating tasks. So it's a lot more task driven. So if a patient DNA'd, it would create that issue. We're looking to creating a task to let the healthcare scientist know to rebook the appointment, and also continue to migrate to .NET 6. So a bit of just the reason why we're moving to .NET 6 was one of the main motivations was the SMS messaging from GovUK Notify. Their NuGet is supported better in .NET 6, whereas previously .NET Framework 4.5 is what I was using. It's not very well supported, and we just had quite a lot of issues with that. So we're using .NET 6 now because it just seems to work really well with the library. And also just a little bit of computer science, AI, machine learning there. It would be really interesting to see whether, with the results that are uploaded and all this data that we're collecting, could we automatically classify the severity of sleep disordered breathing? So those who are familiar with sleep disordered breathing may know that we have something called the oxygen desaturation index or the apnea-hypopnea index. These are numbers. So it could be that we sort of start to automatically think, okay, this person's got a high ODI, they must have some sort of severe sleep disordered breathing, or this one's very, 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 very low ODI, so there's no signs of sleep disordered breathing there. So we could look at doing stuff like that, but needs to be a lot of work around validation and governance around that first. But just an interesting thought to have in the future for that. And that's pretty much it from me. Thank you for listening. And again, I'll answer some questions towards the end.
Raymond, I can't hear you, buddy. You're on mute.
Oh, apologies. Can you hear me? Okay, apologies. Sorry. So I'll just repeat very quickly. So yes, I'm just saying thank you very much, Andrew, you're showing that's showing really a good way of thinking about outside of the box on using tech and engineering to have the visibility on devices and how we can use coding to leverage work and efficiencies and engage with patients and through the reminders and reducing the DNA rate and equipment's loss. And it's exciting to see what will be in the future in terms of the work with the data that's captured and the use of sort of machine learning and AI in that area. Now, Sam will be sort of telling us more about his work. Sam has done some great work on things in terms of oncology, I know he will be telling us more about that oncology and coding, and yes, more about robotic process automation. So yeah, you can start, Sam. Introduce yourself and tell us more. Yeah,
will do. So I'm just going to share my screen now. Hopefully you can see my screen. Is that looking okay to everyone? Yeah, good stuff. So yeah, it's really nice to be invited today. Thanks very much. So I'm going to talk to you about my Clinic Prepper, which is my homegrown healthcare hack. It's a bit of software I made in Python to automate a process that's carried out on a weekly basis. The number of clinicians using it is slowly growing, but for each adopter, it's saving about 30 minutes a week. I'm hoping that it might prompt others to start looking at their own systems and have a few ideas of their own and maybe implement their own solutions, so we can sort of approach fixing the NHS at 1% at a time. So to tell you a bit more about me, I'm an oncology registrar at the Beatson in Glasgow, and this is where this idea came to life. I'm a lifelong coder, started coding when I was around 8 years old on my ZX Spectrum, and I've never really looked back. As a fun fact, I did my computer science degree in 2003, the same year as Mark Zuckerberg. Ironically, he dropped out and I finished my degree, so we can see one there. After my degree, I spent about a decade working in the investment banking IT sector, and then I decided to give up all that money and go to med school, and I've been dabbling in health tech ever since. I started a site called doctorsthatcode.com for other medical professionals who are interested in programming, and I'm about to come out of my training program to do a PhD in AI and cancer, predominantly for cancer patients. And of course, the reason I'm here today is part of the Let's Do Digital team, trying to get homegrown healthcare solutions and open source out there. So to give you a bit of a background of the problem, it's not as established as Andrew's. He's clearly done a lot of work. It's very impressive. So I feel like a bit of cheats coming in with my little program. But I think it's fair to say that I'm sure I don't need to tell anyone in this room that doctors are stretched for time. And to paint a picture of how the clinics work, you have one or more clinicians who have a number of patients to see in a clinic. For this specific example, it was a Monday afternoon clinic. It's a very busy one with up to 30 or 40 patients to be seen in about 4 hours. These patients are spread between a few different clinicians, and in cancer especially, but increasingly so in other areas of medicine, these patients are really complex. They've got complex histories, complex treatments, and the side effects of those treatments. They have genetic markers and biomarkers that determine their treatment options, and then the imaging, which shows the anatomy of the disease, all of which we need to know in order to make decisions about patient care. The pathway for these treatments isn't straightforward. It's not like an if-then-else chain, as us programmers might think of things. There's nuance to it. And I'm sure you can appreciate there's a lot you need to know about these patients that are sitting in front of you, particularly with some of these chemotherapies and targeted therapies, which are weekly treatments. You need a running commentary of what's happening to them, not only for yourself, but also for your colleagues who see them. If one week on next, if you're seeing a patient 1 week and then one of your colleagues takes over the next week, they need to understand your thought processes or what the treatment plan is. You could argue that that's what letters are for, but letters where we work in Glasgow, they're manually typed after being dictated, and I can promise you they're not turned around within a week. But also the letter system is really for information to be given to GPs and other specialists, and sometimes you need an aid memoir. You don't want it formalized, you just need a running commentary, as I mentioned. This probably should exist, but one of the problems with electronic health records or systems that we have is that they weren't designed with the end user in mind. So for an example, the track program that we use up in Glasgow, I've heard rumors that it was actually repurposed as a shipping container software, which does explain a lot about the way we use it. Now, for these clinics that I've mentioned, there's no way to prepare these on the fly. You can't really do that because there's just too much information to get. We've got several different systems that we have to go through, like Portal, Track, and ChemoCare for our prescribing systems. They all hold separate and crucial bits of information. So if you were going to try and do that for each patient that you had in front of you, you would be there till 7 p.m. with angry patients outside and pharmacists getting angry at you because you haven't kept up and you haven't got your prescriptions in for the next day. So we prep. And this process is time that's not usually accounted for. It takes a surprising amount of time. We need to update the document that has this clinic prep on each time that we have a clinic, which is weekly in this case. And it's a lot of just copying and pasting from the previous documents. And as you can imagine, it takes a lot of time. It's very copy and pasty, and it's almost like a robot could do it. Aha. So where the idea really came from. So one of the benefits of having a reputation as the guy who can code is that I'm asked to help with little programs here and there for colleagues, particularly in what I do, which is a lot of research stuff and a lot of data collection and kind of looking at data, which gets you exposed to some really exciting things. And so one day, whilst actually doing my own clinic prep, one of the consultants suddenly appeared next to me and said, "Oh, Sam, I hear you can code." And we started talking about automating this process. We took a really high level viewpoint from the process perspective and thinking about what was happening, taking a copy of information stored and basically creating a new document and perpetuating that document and making sure that there was the most recent document and the most recent information for this patient. This is obviously something that can be done via computer very easily. It's simple. It doesn't need anything clever. It doesn't need machine learning or AI or anything like that. It's just a number of people are using the same manual process because no one's come up with a better way of doing it. But as with anything in the NHS, whilst it can be done, you've got to ask the question is, can it actually be done in the constraints that we have? There's a lot to this. We can't just be making software and installing software on PCs in the trust for obvious reasons. Data privacy, security leaks, etc., etc. I'm sure we've all seen in the recent media how there was a massive data leak with patient information going on the black market up in Scotland. So there needs to be a process of authorization. It needs to go the equivalent of eHealth or whatever the responsible party is at your local trust. And you could argue that making a bit of software that's going to have access to patient information and then provide a clinician with a summary needs to go through all kinds of validation and testing and checkpoints before it can be used. It represents a risk not only from a security perspective, but from the responsibility perspective. If you're using a program to make decisions about a patient, you need to know it's accurate. Now, of course, in a perfect world, that will be totally true. But there are two issues. At the moment, the current process involves a tired clinician, probably working out of hours or at the weekend, copying and pasting 40 times from various documents. This process is going to go wrong. And when it does, it's picked up because there's several of us who check these things. It's rare, but it does happen. And as long as you go into this kind of change, making this sort of change with your eyes open and understanding that this is a time-saving device and not an infallible solution, then hopefully you'll have an appropriate degree of care and diligence when using it. And the other side of the coin as well is the journey to get something done by eHealth seems almost impossible. I understand Andrew managed to do that and he's got a team together, but it's quite difficult when you are a clinician trying to make a change to your process, to how you're working with your colleagues. There isn't the capacity to do that. And there's a lot to be said about getting changes into the NHS. And I think that's a topic for another time, but it is a struggle. And if you can find a way to save half an hour, 45 minutes to a handful of clinicians every week, those savings will add up quickly. So before delving deeply into the analysis of the process and starting to try and code something, I think it's worth asking your IT department what rights you can have, whether it's admin rights to install a compiler, making a sensible decision about what you need to do and how you can provide that solution. It's unlikely you'll be given long-term admin rights to access or change path variables or create executables or things like that. I certainly had to plan for this kind of thing with Clinic Prepper. In this case, as a medical oncologist, part of my job, as I mentioned, is to do analysis, statistics. We already have access to things like R, so getting Python wasn't a million miles away from this. So it's probably an easier sell for me than for most. But onto the work itself. So I can't overstate the importance of sitting down and working out exactly what happens and how and when it happens. There's nothing worse than spending about 100 hours building something that works fantastically exactly as you designed it, but it doesn't actually fix the problem or work in the situation. And believe me, I've been in those situations in my professional career, and they don't feel good. And even for making this project, knowing what I know and bringing it to the situation, I still made some assumptions, and that ultimately needed changing. So you've really got to get this thing right early doors. One thing I know about healthcare and health industry is a single click, a single extra problem, a single extra step will stop people using it. So you've got to get it right. So the fun bit, turning the current process into a plan for your code. I'll try and give some context rather than going on at being abstract. This is completely fictitious, by the way, but I just wanted to give you a level of the complexity that we're bringing to these summaries. So it's got to be a several sentence, or at most a paragraph summary. So a 67-year-old patient with an adenocarcinoma of the cecum, they're microsatellite stable, they're BRAF and KRAS wild type, they had their surgery on the 20th of April. They've come to us for adjuvant treatment, which means after their surgery. Their DPYD was heterozygous to mutation. The treatment they started was capecitabine and oxaliplatin on the 1st of June at 80% capecitabine. Neutropenic, developed persistent peripheral neuropathy after 2 cycles. Oxaliplatin held for cycle 3. Capecitabine dose reduced to 60% following neutropenia. Now, that's not going to mean anything to a lot of people, but if you can imagine, to build that story, you would need to have gone through about 8 letters. You'd need to check 2 or 3 different systems, get all those details. And having that as you sit down in front of a patient is so critical. And for the planning stage, you have to realize where these bits of information are pulled from in order to kind of get your solution together. And then you want to break down the problem into simple steps. As for any process mapping, the granularity is important. So you start with your basic flowchart above, and then you break down each of these components further and further until you've got a simple step-by-step process. And as you can see from above in this slide, something like read spreadsheet into program, that obviously needs to be broken down further. It's not like you can just type that into Python, it will do it for you. Although AI, I suppose, is another case. But you've got to think about, is it going to use a graphical user interface? Is it going to default to a certain directory when looking for the spreadsheet? What version Excel will it be using and accepting? What data structure will I use to read the information from the spreadsheet into the program? So all of these decisions have impacts. To give an example, during this actually, it was an amazingly annoying example, which caused a huge headache for me, was the difference in Word versions. So when using a desktop PC in the trust, they used an older version of Word and had a .doc extension. So, of course, I did my coding work and my testing work, and everything was looking beautiful and working perfectly until I installed it on the laptop and asked the consultant to try it. And, of course, it collapsed in a total heap because the remote desktop had a much more recent version of Word that used the docx extension. Now, you might think, oh, that doesn't really matter, surely, but it really does. It stopped everything working and took about 4 extra hours of code trying to find a sensible way of converting .docs to .docx's in the constraints of the system without violating any of the problems with security and all the rest of it you have to be really careful of. So I guess another lesson is that you can't really plan for everything, and end user testing is critical from the start. I think further to that point, for those starting their journey of coding, you'd be amazed at how quickly these things grow arms and legs. So version 1 of the Clinic Prepper, which you've got in front of you there, is as basic as it gets. With all the testing code stripped out, it's already at 400 lines of code, and that's across 10 Python files and about 81 lines of comments. Now, it's doubled since then because it's got a friendlier user interface and there's some customization. But I guess the point I'm making is these programs get big quickly. You've got a plan for that, and your brain has to try and hold on to the structure because you're going to forget what you've done and the rationale for why you've done. So leave yourself comments, leave yourself breadcrumbs, and really think about the logic of the program. The best programmers I've ever worked with are the ones who spend less time typing and more time thinking about the solutions. And this is mainly for the people who are thinking about getting into coding, but a system I've developed over the years is what I call the 3 M's of software development. So it's making it modular, maintainable, and minimal. There's a lot of best practices out there from test-driven development, extreme programming, agile development, but they all at the core follow those kind of principles, just making it as simple, testable, and modular as possible. So the clinic prepper itself, I think, just again, for people who are interested in building something themselves, try and make it as logical as possible. Don't worry, I'm not going to go through everything line by line with you here, but you can see I've broken down each major process into steps. So you've got importing the Excel file, organizing and getting a list of the previous documents, getting the new document list and converting them to docx's, importing the patient information, building the Word document, and then outputting the results. So you know if something goes wrong at some point, you know where you need to look. You need to look at which module, and it's all separated out and built out nicely, so you can see how to deal with the problems, essentially, which is probably 90% of programming. So the challenges of building homegrown solutions, I think finding time and finding the bugs, just to reiterate, really, this stuff takes an amazingly long period of time. And you have to think to yourself, this simple program, I'm going to smash it out in like a day or 3 days. And then come a month down the line, I'm still working on it, you know, scratching my head, trying to work out why 3 patients didn't come onto the list this time, where it seemed to be working before. And just in this particular case, it was because their date of birth started with a 0, so it's like 01 or 02. It's like single digit date of birth. That my program had only experienced people who had birthdays after that, so I had to add extra logic and give you an example of having to completely rethink the system. For the initial plan, the primary key for my dictionary told all the information about the clinic was the clinic time. It made sense. It seemed to me the most logical key to use, but what I didn't know was that when the clinics are extremely full, they book patients on the exact same time slot. So immediately that fell apart. So I had to redesign and rethink, and decided to create a clinic patient class to prevent such errors in the future. Then after I did that, a week after I implemented it, the beautiful clinic patient class that seemed to be working brilliantly, the system broke completely without recovery. And I discovered not only do they double up the booking times, but I'd created a date time to hold the clinic time. And sometimes the track system adds a B to the time slot. I don't know why yet. I still don't know why to this day, but I can tell you my date time variable didn't like that B very much. And so it all stopped working. And these are the things you find out as you're going on, as you're developing it. So I suppose just to really say about the finding time to do these things, when you're trying to fit this around your actual job, i.e. what you get paid for, as well as being a parent and a spouse and all the other things in your life, just know that this is going to take more time than you'd ever expected, and not the least to expect it to take a bit of extra time when someone asks you to present it in a webinar and you've got to clean up your code in case anyone downloads your GitHub. So coming back to working with the constraints of the system, so getting a Python compiler and making sure you have safe imports and you can't leak any patient data is critical. Working on the NHS hardware, for which every compile is taking 1.5 minutes. You've got to be prepared to work within those constraints. And when trying to get a virtual environment working for this Python code, I was fighting between PowerShell and VS Code terminals, trying to get the correct path on the C drive to give VS Code access, because the system had been so locked down and there was only semi-bizarre paths I could get to make things work or run scripts. It's a challenge, and it's certainly, you know, it's not an easy one to overcome. So you've got to think and work with IT where you can to try and make these things work without causing any problems. Working with the end users is a really important thing. Everyone in the NHS uses IT, but many of them, especially in the field of academic oncology, at least in my experience, no offense to anyone who is, but they're not computer savvy, and why would they be? Which means at the end of the day, the system has to be as user-friendly as possible, to a fault, in fact. Build your system with this in mind. Every click counts. Plan for a completion strategy. You don't want them needing to launch a virtual environment and compile something in order to run the program. That's probably not going to work. So you've got to think of a way that this can be implemented realistically. Testing with the end users. This is tricky because quite often these are people who are time constraints. You don't have time, both of you at the same time. But it's quite a thing as well to say, I'm expecting this to break. I want you to sit here, try it, and let me interrogate why it didn't work as expected. People don't realize that's part of the process, and you really have to manage expectations here. And alongside managing expectations, I think with that lack of understanding, it really does bring a lack of appreciation for what's required. So, I mean, a couple of things that people have said to me is, oh, your program can summarize my patient for me. That's amazing. AI, right? Can you set it up on my machine? Or better yet, was actually from one of the people in the team I work for, and they said, "Oh, I've got a clinic tomorrow, different clinic, no idea how they work." And I received it at 4 p.m. the day before, and they said, "Oh, can you get your clinic prepper thing working on my system? Can I get it in time for tomorrow's clinic?" You just end up disappointing a lot of people, I think, unfortunately, but that's the reality of it. So the limitations of this system, there's a lot of limitations. It's really specific to a certain team with a certain workflow. It can be adapted to be used other teams if they have a similar process and need, but it definitely won't be useful for everyone. But if I can save 25 oncologists 30 minutes a week, that's 12 and a half hours a week saved on copy and pasting. And I think that's got to be worth it. I think as a final thought, we should all be looking for ways and opportunities, low-hanging fruit, where we can build something that might save these time, because these things add up. So that's me. Thanks for listening. If you want to check out the program, it's on GitHub. It's free to all. And for details on my clinic prepper journey, I've just popped it there on doctors.code.com. Thanks very much. Ramon, you're muted again.
I need to work on my. No, really, thank you very much, Sam. That's a really great way to show end-to-end way of thinking about the workflow, how to plan it, process mapping, and getting sort of the right access, and going through the hoops of governance and all of the tech.
The endless hoops.
It is. And let me ask you. I'll start with you, actually, Sam, with a question about that I've seen that says, what is the best approach? Because it is quite challenging. So from the tech availability and accessing the data, and as well as sort of getting the buy-in from IT team. What was the any learnings that you would like to share with us in terms of how was sort of what is best practice?
Yeah, so I think you've got to be upfront from the start about what you're trying to achieve, and if anything's going to be stored. One of the first things I had to declare and make sure that everyone knew is nothing was going to be stored anywhere. Nothing was leaving trust computers. Everything's going to be a single use, copy, paste, and ditch. There's no storage in the program, and that's really critical, and it can't go off site as well. And alongside that, that's one of the problems of final implementation. So I'd love to make this a web-based system or something other people can use around the country. I'm sure there's loads of people doing something similar to us, but that's not possible because that would involve patient information leaving the site, right? So you've got to think about that. I think getting a compiler and getting something that works is step one. So I would say have that conversation with IT first and see what you can do. But to be honest with you, like I've got quite a few years experience working in IT, and getting it to work around the constraints was really hard. I had to use some really backdoor knowledge, things I just know from years of experience, that in order to get a virtual environment that will actually run a bat script, like you're not going to be able to do that most of the time. That's very locked down stuff. So you end up going through multiple virtual environments to try and find one that you can actually work around the constraints. So it is challenging. If you've got a good idea, I'd say find someone who knows a bit about it, and then you could probably do it with them because, even as a mentor or some kind of assistant thing. But yeah, I think honest and upfront, make sure they know your patient data isn't leaving, and then make sure that you're definitely not doing anything you shouldn't be. And if you're going to do any testing and you want to put it on GitHub afterwards, make 100% sure that there's no patient information that could accidentally have leaked up, because that's something I was extremely paranoid about, and I ended up only doing it at work, which is one of the reasons I had the problem with laptops. Because I was like, I can't even take the risk. It's not worth it. I've worked too hard to get where I am to lose it for a stupid data breach. But yeah.
That's great. Thank you very much. I have a question for you, Andrew. So it's about did you guys sort of look at how you've saved sort of the number of hours that been put in work and then implementing the new process? Did we look at how we saved that sort of in hours or a workforce?
Yes, so I've just done a very quick back of a packet calculation here. I haven't looked at it too much detail, but
Sure.
I reckon it's at least 2 hours a week because so the auto SMS messaging would say between 3 to 5 minutes per patient because this, you'd have to log on to GovNotify manually, find the number on Camis, type the number up and all that. So now the number's all stored in one place. They can just press the button and it just does it all on the API. Chasing patients as well to bring back equipment. That could take, now that it's on one list, again, that's about 5 to 10 minutes per patient just to try and find the number, what equipment it was, and all that's gone now. It's just straightforward in front of you. The number's there. Yes, you might have to go to Camis just to check some demographics such as date of birth and address, just to verify it, but it's a lot quicker. But just thinking of that though, it's been 12 months since we've launched it now, so it's quite, I think it's probably one of those times now where we do look at maybe checking our DNA rate, because I know just through observing the clinics, we've noticed that more people are attending, but to get some proper numbers from the last 12 months versus the year before, I think that's definitely something that we'll look into the next step, I think.
And thinking about the savings that's been done from people turning up to, yeah, absolutely, absolutely, fantastic. One more question for you, Andrew. It's I've got a question here. Says looks like you had an NHS style buttons. How did you create these, and are they from a standard library?
It's a good question. Yes, so I probably should have put that in my slide as well, but it is actually from an NHS standard library. It's from the NHS Design Library, and you can find it from NHS Digital or NHS England. They've changed it, but it is also on GitHub. But yeah, if you Google NHS Design Library, everything's there. There's component guides there, so you bring in the style sheet. So it has a CSS file that I've used. Bring in the style sheet. I use the component examples on the NHS Design Library. Just go on to view source, copy and paste it, and there we go.
Fantastic. We will try. We'll get the URL and I will put it in the chat. So for sort of anyone who's interested to follow that. Any more questions from anyone? I think that's all the questions that I have. If anyone wants to follow your great work, where they can find you? Where are you on LinkedIn, or are you so that we can sort of, anyone wants to know more about the work you're doing?
So yeah,
I'm for me. Yeah, and Dr. Sam. I'm sure you'll see me popping up, and I'm also on Doctors That Code. I put my musings on there, so anyone who's interested.
For me, find me on LinkedIn, add me. I did have a personal website. I'm in the middle of revamping that. It's andrewsimpson.dev. So just I need to sort that out. But yeah, find me on LinkedIn. Perfect. Twitter, Andrew L. Simpson is my Twitter handle as well.
Perfect. That's great. Thank you very much, Sam and Andrew. We don't have any more questions, but that's really, really good. Give us an idea and a flavor of what can be done. Going up to healthcare with tech, how we can bring efficiencies, which is sometimes quite challenging and sometimes uncomfortable, sort of to go into sort of a different domain, different area. But I'm sure with your great work, things sort of and sharing all of this great stuff that help people to learn more. I'm really grateful. Thank you very much.
Cheers, team. Take care. Bye.
Thanks very much. Thanks for inviting me as well. Take care now.